Hey everyone, welcome to this video. Today we aim to simulate residual stress analysis using SYSWELD. So I opened the Visual Weld. Here we have the 3D MMA model which was in the previous video. So take a look at it. So I open it. This is the model. Go to the Welding Advisor, and here we double check everything. It should be on solid, and these are 316 stainless steel the material, and it joins with filler. The filler material is also 316, and we have here this is the source and the weld pool. The numbers, the velocity is 3.5, 8.5, 10, 6, and 5 here, and the energy is as follows. And here we have the cooling condition, and the most important part is the clamping condition. As explained, these residual stresses having a direct relationship with the clamping conditions, so we have to double check here. There should be this side is on UX, this one is on UZ, and this one is UX and Z, and the time should be from 0 to 2500 for all clamping conditions, and we don't need it function database or thermal mechanical here. And here we should check this mechanical in order to have the residual stress analysis or mechanically analysis inputs. So we check this mechanical and we generate input file and click on yes. Now we want to solve. We click on 3D MMAW and we hit open. So here we have the box to do the analysis, and we don't need to check the thermometallurgical analysis. We only need to check mechanical, and we hit compute, and from here maybe we can do a multiprocessor analysis in order to finish the simulation sooner. So I use the maximum and enter. Now it is calculating. Alright, it is completed, and now we're good to look at the results. Okay, to see the results we want to open the visual environment and go to the visual viewer. Here we go. We want to open the file. So if you look at the results, in the results section, we previously just only had post 1000 FTB. Now while we do the mechanical testing, we have post 2000 FTB. This is the code that the SYSWELD software has. So if we want to look at the mechanical properties, we want to open the post 2000, and if we want to see the thermal analysis, we can open the post 1000. It's a way to distinguish them. Right, this is the model we have here. Let's see the contour. Here we have different results, and we also You can see the temperature results as well. So it means if you do the process, the mechanical, it contains more option. It not only has the temperature but also has the stresses. So we don't need the temperature here, but we want to go to the stresses. Here we have the element. You see the node element 1. This is the residual stresses after the weld was done. Here you see the highest stresses are here in the clamped sections, and if we look at it from, I think, this side, you see it is kind of bended. We can start the process and see it is kind of bended. Alright, let's look at other results. Here this is the XX and this is XY. You see the bending here is more visible. It's kind of distorted. Okay, we come back to the isometric view. Let's jump back to the stresses here. The node results, stress node. We have the von Mises stress, Tresca, and here we have the stress in XX direction, the XX stress component, and the thing that matters for us is to plot the residual stress. So we want to go to the file and from important plot we can create a path here. So from instead of node we go to the profile curves and we create a profile curve. Let's do a transverse, and from here we can go to the top view and here in the center we can create a path. We carefully select all the nodes so I would like to undo here. Oops. Let's zoom in and select. It was better that I selected the upper line, so it is still okay. We can see the trend. Alright, we created a path, and by clicking here and here we have our transverse one. We want to create another path in the longitudinal direction, so let's create a longitudinal path, and we can select. Right, we have selected a longitudinal path as well, and here it's better to determine the has region, and after that you can do residual stress analysis and see the results in the has, and as you see they would be probably much higher. So here from the transfers we are going to go from S stresses XX and plot in the transverse direction. As you see here, the trend is the same. If I was on the other line I told you, it might not be like this, but the trend is pretty much the same as what I showed you. In the weld direction we have pressure stresses here, and we have tension stresses here, and it is so high. And what we can do is to look at this, to plot the stress in YY direction. You see here, this is the YY stress in the transverse, and we can also plot the YY in the longitudinal direction. As you see, the trend is the same, and we can plot them in the XX direction. So as you see that the residual stress in longitudinal is not that much in the XX direction, but if you plot that in the has region, you're going to have higher stresses. So we come back to the page 1, and you see here the highest stresses should be here. So if we select it here, it would be better, because you see the path we selected doesn't contain the highest stress in the middle, and that's why we have a reduction. But generally it is okay. So if you are doing the analysis and creating the path, you can create this line, which is better. So that's it. It's pretty much everything. I hope you enjoyed this video. See you in next one.